Welcome to our business track of the Data Science Salon YouTube channel. In this talk, we have Jeff Sharpe, Senior Manager Technical Lead of Enterprise Platform Products at Capital One. As machine learning and automated decision maker takes on a bigger role in all of our lives, engineers and scientists are building those solutions that have growing need for organized, reliable, and trustworthy way of handling their data. So far, data platforms are most popular in large enterprise platforms, and while their usefulness there may be easier to justify, many of the most important arguments for them are universal across all usages. And in this talk, Jeff will explore some of the most important reasons why you should invest in the infrastructure that's feeding your machine learning models and how it can solve problems you may not know that you had. Enjoy the presentation.
Hi, I'm Jeff Sharpe. I'm coming to you from Capital One to talk to you about data platforms and why you need one. So I am a senior manager with Capital One working on their enterprise feature platform. This is a platform that Capital One's been developing to kind of unify their overall approach to how we handle data, specifically features for machine learning, but also for various other things that we depend upon a stable data sources and stable data policy. We can start off this discussion really with addressing what a data platform is. I'm using this as a really kind of generic term to address pretty much everything that you use to manage, control, and kind of provide access to your data, whether that's for a large enterprise, small company, even just a small dev team. It doesn't really matter. If you're doing work with data, you have a data platform. It just might not be coherent. Maybe it is coherent and it just needs to be reworked. Maybe you've already adopted a lot of these strategies. I think overall, there's a lot that you can look at to try to make things a little bit clearer. And we'll run through some of those patterns that we can use to kind of improve how we're using data platforms. Whenever we talk about data platforms, one of the first things that generally comes up is a discussion over exactly what we mean by data. In this case, obviously, a forum like Data Science Salon, we're often talking about machine learning features. These are things that we're going to be used to go into machine learning models. They're going to feed deep learning algorithms. They're going to feed various things that may be having older style models like Bayesian models. All of these end up being features. It's all ultimately data. The other things that get looped in here also are just other types of data, and they can easily be thought of as features, and it depends upon your perspective. Business events. So these are just the raw things. Most of the financial industry is used to thinking of customer transactions as a very specific type of data. Ultimately, these are just business events. They're the same as gathering a click stream off of a web app or being able to understand individual customer requests from a mobile application. Similarly, all of the results of the things that the software is doing also end up being events. So the decisions that your machine learning models make, application decisions or various events that occur based upon inputs to applications end up also being business events. These then can be fed back into machine learning models as features, or they might just be used for reporting or for making rule-based decisions. And finally, metrics end up being another type of data that has to be tracked the same way. Again, we see the same pattern. Metrics can very easily be features. However, in many cases, they're treated slightly differently and yet are very important to be able to categorize and understand and monitor in a way that makes sense to you. There's a lot of interesting things that come out of this. Monitoring application behavior, being able to make assumptions based upon how customers behave, or how often some of your machine learning decisions are successful. Being able to curate, understand, and look at this data becomes very important to any sort of data platform or any usage of machine learning data. Now, this is a little bit, I guess, biased in that I have seen these kind of patterns around. This is not atypical data platform for what we might see in just an average place that's using some amount of machine learning, some amount of data warehousing. One of the main things to note here is that it's not terribly organized, and that is a biased approach. We have different inputs going in different locations. There's no real flow that says, here's where I come from based upon what kind of thing I am. I have some of these use cases are talking directly to data stores. Others are talking through various other interfaces. And at the end of the flow here, we have machine learning training and analysis. And if you look at the relationship between the machine learning training and analysis and the application events and the business transactions that they're supposedly based upon, we see several different steps and several diverging paths that all end up in the same place. This ends up being kind of a bit of a liability for your machine learning and training, and doesn't really help everything else that's in the middle. So looking through this briefly, we see a whole bunch of weaknesses. As I pointed out, we're not sure what the data flow looks like. It's not completely clear. There are different cases where you end up changing formats from one data storage to another as you move from a data warehouse to something that's more suitable for operational usage. The access control is kind of all over the place. Obviously, it needs to be applied in all of those locations, but since the locations are so dispersed, your access control has to similarly be dispersed. We had cases where we have tight coupling. The software may be talking directly to the data store, and that means that your software now is specific to that data store. Attempts to update that is going to cause some problems. Most importantly is the duplication and inefficiency that we can see in this. Some of these events are being stored in multiple places. Some of the calculations behind those events might be done multiple times. And the reality is that you simply don't know whether or not there's duplication. You can make the assumption that there is, and that's probably enough to prove that it's not necessarily the ideal situation. So let's try to come up with some ways of improving this. The cornerstone of any modern data platform is ultimately knowing the data that you're dealing with. If you don't understand the data you're dealing with, you don't really have much hope for being able to build a coherent platform around it. Gathering information about the data, not just the data itself. It doesn't mean putting it in one place. This means being able to know for a particular type of data, a field within a spreadsheet, if we think of that. What does that field mean? Where did it come from? Who's responsible for it? When we think about this from a more generic sense, we are really talking about being able to know how a calculation was done, who owns it, and what exactly is that calculation. And that's in human terms. So describing it in a way that another human using the platform will be able to know and understand. This is the goal that it is. It is the number of transactions that have come in for a customer. It is the number of times that a customer has clicked on a particular page, or maybe the number of times that they've logged into a mobile application. Once we have some of that, we can start correlating that with other important information, analytics based upon that data. As we generate analytics, we want that directly linked to the data. We want to be able to directly link the access control with the data that we know that we have, so that not only do we know about the data in one central location, but the access control is controlled and actually kind of cataloged in one single location. And finally, one of the more important things for all of the data science users out there is understanding things like freshness. So I use freshness here as kind of a stand-in, but it ultimately becomes something like, how often is this feature updated? How suitable is it for use in my machine learning model? Is this the sort of calculation that I'm actually looking for? Or do I need something that has more accuracy, is updated more often? Knowing these sorts of things ends up being the most important foundation to build the platform on. So next, beyond that we need to think about how people are going to access the data that's actually on the platform. More than understanding the calculation patterns or the way that it gets written is understanding how people want to use it. Maybe this is one of the most important things about understanding designing these platforms, is to think about it from a case of who is going to use the data rather than who is going to generate the data. We have a number of different categories here that we'll run through really quickly. Obviously, the kind of standout star here is the ML training. This does end up having a strong use case for data platforms. This is bulk data. You generally don't have a need for this to be high speed. It's all about being able to find some way to get the data as quickly as you can, but only on a case where you're trying to retrain very quickly. If you're going through normal training, days are fine. Batch calculation is another form of that. Again, you're looking at some sort of timeline, but it's generally just once per day kind of thing. Speed is not a concern. Access to a large amount of data is a concern. Then we get into some things that are a little bit more interesting. Now, real-time decisions do need very fast access, but generally they're looking at very small amounts of data. And finally, business analytics are kind of a grab bag of everything else that we went through. They can be a little bit of everything, and it's possible for them to mix some low latency requirements with some large volume requirements. What this kind of means in the end is that we have a situation where we have different patterns, and from a technology perspective, ultimately means we need to think about different ways of providing those. So one of the first ways that we can help accomplish this is to get rid of that pattern where we separated out all of the different ways that data was collected. So in the original diagram, we saw data being generated in multiple different places and kind of stored in the convenient patterns based upon where it came from. One of the first things we want to do is unify that data collection. So try to make all of the data that you are generating, have it go through a central location. It doesn't necessarily mean you need to bottleneck it through a single service. You can certainly separate these things out, but you want it to be some service that is integrated with that data catalog that describes all of our data and allows us to know as the data comes in, yes, it's this type of data. This is the field we were expecting. This is the data source that we were expecting. Here it came from the owner that we expected it to come from. And that will importantly tell us where we should put it based upon that sort of information. So here we have it being split out into 3 separate data stores. A data lake, a time series, and a low latency store. You'll see that these kind of fit the previous requirements that we had for retrieving data. Data lake is going to obviously do very well at bulk retrieval. A time series gives us an interesting view of data that may change frequently and that we need to address for windowed calculations on machine learning models. Low latency store will give us the very fast access that we need. And we can separate these things out. There's no reason that they all need to be populated for every piece of data that you want. And that's one of the reasons why you have that unified data catalog. We want to be able to make that decision intelligently in one location so that it can be the authority on where our data is going. That also becomes then the authority that tells us how we're managing our data. If we have questions about where data came from, the data catalog and this unified data collection help us answer those questions. The other half of this then is setting up the data retrieval based upon the type of data that you need and specifically the pattern of how you're going to read it. So again, we see the data catalog playing a big role here. We have our data sources, and we're going to have a single sort of API that's going to sit between our data sources and all of our use cases that are reading the data. Again, this doesn't need to be a bottleneck. They can be separated out so long as you have all of them kind of following the same pattern. In this case, they are all abstracting the idea of the storage, and they're providing an API based upon the type of retrieval that's being done while integrating with the data catalog. In this sort of pattern, it allows you then to change the type of storage that you're doing, the technology behind it, the configuration, location, all of those things can freely change to meet your needs for storage adjusting for cost, performance, and those sorts of things without impacting the actual use cases. Now, this lets them treat the platform as a simpler service and just base it on what they need to get done with data and how they need to interact with that data. Now, taking this one step further, we do have the idea that says once we are collecting enough of that data and we can see people using it, understanding how they're using the data, being able to look at the actual data that we're collecting and that we're sending out, we can develop generalized ways of doing data analytics and analyzing the usage of that data from all of those use cases. Since we've generalized all of the storage to a level that at least we understand all of the schemas and technologies involved with it, we can actually have a small number of generalized services that provide all of these things for us. This wasn't something that was possible in the more spread out, undirected flow that we first looked at. Now, in this, you can see all of these data analytics and things like anomaly detection. It's actually based upon the same APIs that we used for use cases, and we're actually going to feed it back into the data catalog. Now, this lets us have the data catalog then report back to the users as they look through the catalog. Here are the usage metrics. Here are the data analytics. This feeds some of those freshness metrics that I talked about earlier. When we have something like a feature that doesn't get updated for a while, or a feature that fails to meet some expected variance. Maybe you see that the number of users who are clicking on a login page suddenly triples. That's an important thing to note, but it might just be a case that says the way that we're collecting that data is no longer as accurate as we thought. Maybe it's counting, the number of times that failed logins occurred as additional logins, and we need to look at that. Being able to feed that back to a data catalog so that people looking to use these things, that they're looking at these APIs, they can see what the analytics are for those features. They can see what all of the usage looks like, just in case it's not going to meet their needs. Now, I'll throw this in just as an extra topic. This is something that is actually kind of important for Capital One as part of the work that I'm doing for them. We've gone one step further, and we actually are moving some of the feature calculations into the data platform as well. And this is a little bit more controversial. A lot of data scientists have very specific flows and very specific tooling to help them do feature calculations. There are a lot of products out there that will help you do these very efficiently. At the same time, understand that there is some efficiency that can be gained from doing this particular integration. Notice how the data catalog now plays a good role in the feature calculations. Not only can we describe the features that are going into the platform, but we can actually see that the integration between the two means that the catalog is a little more accurate. It knows exactly when the calculations occur. It knows exactly how they're occurring. We can link to things like the source code involved, the schedule that feature is being calculated on. And we know that the feature calculations make it into the platform because it's part of the platform. This does have some additional complications to it. You can see now we have to think about data sources. We might be able to feed some of our calculations based upon our own data platform REST API, but you will end up having more sources of data that you need to curate. This involves a lot of closer interactions with data scientists. So this is not a simple task to take on, but there is some value to be gained by actually bringing calculations into your platform. Now, here's the final overall view that you can kind of see. In this, I'll call out a couple of very important things that stick out to me, at least as a technologist. We have a data catalog, and it's hanging out in the top, and you can see how it's kind of reaching into all the different parts of this platform. This is echoing the earlier statements that I made. The data catalog, understanding your data, understanding where it came from, where it's going, and how it got there is one of the primary important things that comes out of this particular data platform. it ends up being the sort of foundation, the fabric that all of the rest of this is built upon. We have a single data collection pipeline that leads into the platform, a single API that leads out. This ends up being the abstraction layers that all of us engineers like so much. It can be a source of friction a little bit, but it is worth being able to manage the input, manage the output, and get a good understanding of how data is entering and exiting the platform. You can see some of the things we've solved by doing this. Some of these may be a little bit subjective, but we do have a simpler flow. We know the entry, we know the exit. We do have more uniform data. Since we combined all of the input into a single place, we can guarantee that it's being the same data that's written to multiple locations. This becomes very important for machine learning, which wants to have the same data for training as it does for operational use. We do have a more centralized access control because we reduced the number of interfaces that applications are using. We have the ability to kind of decouple the storage and calculation. The storage is now an interior thing that's managed by the platform and doesn't have to be something that the rest of the calculation or applications need to really know about. Importantly, we have tracking for usage and ownership. So since we know who owns data and we know who's using data, you can actually connect those two people so that someone who's using a particular feature or a particular metric, they can reach out to the owner when they see something going wrong, or they can reach out to an owner just to find more information. Finally, there's discoverability and transparency. This means that data scientists will be able to use the platform to find data in the platform and to see whether it fits their needs. This ends up being one of the main tools that we use to reduce the redundancy that we see in so many calculations today. We want to really only have some of these calculations done as few times as possible. And having the ability to find out whether somebody has already done what you're about to do is one of the best ways of solving that problem. So what's the point? Driving goals behind a coherent data platform revolve around reliability and trust in your data. So ultimately, this is what we're targeting. It seems like there's a lot of work here to restructure a lot of things that exist. The goal in this is that you have to understand that without being able to trust your data, that it doesn't hold as much value as you think it does. This is going to become increasingly more and more urgent as more machine learning makes it into the world. Machine learning models have the ability to make very powerful decisions, and training them is an increasingly popular thing to do, but we need to make sure that as we train them, as we use them, that we are using them with data that we trust. And without being able to know where your data came from, without being able to control or understand so much of how the data is being handled, it is very, very difficult to trust data. So we'll hit on this just again, knowing the data, being able to leverage reliability of the data so that you know that no matter how you request that data, that you are going to get the same data that you expected to find. Being able to detect changes in the data, being able to know that the data you pull from a specific API is the data that you were looking at in a catalog. This ends up being a lot of what we are looking for in a data platform. This is really the cornerstone and what we're looking for as a general way of trying to increase the viability of machine learning, increase its role within business practices so that we can continue to have this really transform the way that so many enterprises and even small businesses are dealing with customers and their data. All right. Comments, questions?
That was the presentation by Jeff Sharpe, Senior Manager and Technical Lead of Enterprise Platform Products at Capital One. And Jeff shared some of the most important reasons on why you should invest in infrastructure that's feeding your machine learning models and how it can solve problems you may not even know that you have. If you enjoyed this presentation, please make sure to subscribe to our YouTube channel below. Thanks!